Welcome to the Titus Timeout podcast. My name is Sean White, and today I will be discussing general water coil design rules of thumb. In general, you can see on this slide, there are several rules of thumb to keep in mind when designing a coil or even selecting a water coil for a fan coil or a terminal unit. You can see here that as you increase the number of rows, several things happen. First, the air pressure drop through the coil increases as you add additional rows to the water coil. You can see here in these pictures, we are showing an example of the side view of a 4-row water coil, 6-row, and 8-row water coil. You can see that as the air travels through the water coil, there is more and more resistance due to the tubes and the length of the fins that the air has to get through, and this is what causes an increase in the air pressure drop through the coil. In addition, the total capacity of the water coil, whether it be heating or a cooling coil, will increase. More rows means more water being exposed in the hairpins to the air stream. Also, lastly, as the number of rows increases, generally the water pressure drop through the coil will increase. More rows in the coil means a longer path that the water has to travel through. This can be mitigated by increasing the number of circuits, and we'll discuss that next. Another aspect of designing water coils is the number of circuits in the coil. A circuit is an individual, unique path that the water will travel through the hairpins in and out of the coil. Circuits don't mix with each other. While the total number of hairpins and copper tubes inside of the water coil remains the same, the circuiting of the coil is how these hairpins and tubes are divided up. One circuit equals one pathway for water to flow through. So as we increase circuits from 1 circuit to 2 circuit to 3 circuit to 4 circuit, so forth and so forth, this increases the number of pathways individual water molecules can travel through. Again, the water in each circuit does not mix or mingle with the water in other circuits. So as we increase the number of circuits, the air pressure drop through the coil will actually remain the same, because we're not increasing or decreasing the number of rows in the coil, therefore not changing the number of obstructions the air has to get past. We're just simply dividing up the hairpins and copper tubes differently. Generally speaking, increasing the number of circuits will actually decrease the capacity of the water coil. The reason is that, for an example, on an extreme case, take a 1-circuit water coil. That means that water molecules entering the water coil will travel through every single copper tube inside the water coil. These water molecules, therefore, will remain in the water coil for a longer amount of time. This increased time inside the water coil gives more exposure to the water molecules to transfer their heat either in or out of themselves into the airstream. So by increasing the total number of circuits, the overall heating or cooling capacity of the coil will generally go down. And this is because as we increase the number of circuits, we increase the number of pathways in the coil, but also at the same time decrease the length of each pathway. Therefore, the water molecules do not remain in the water coil for as long when we increase the number of circuits, therefore shortening each path. However, an upside to increasing the number of circuits is that by creating more pathways that are shorter, for example, a 10-circuit coil versus a 1-circuit coil, we shorten the length of these pathways, therefore decreasing the length of copper tube the water molecules have to travel through. So by shortening the length of the copper tube that the water molecules have to travel through, a shorter path means less pressure from the pumps required to drive the water molecules through this shortened path, therefore dropping the overall water pressure drop. This again should be balanced with a decrease in total capacity of the water coil. So adding circuits will benefit the required pump pressure, but at a cost of dropping the water coil capacity. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.